So let's just think about a function, a nice simple one. What about f of x is equal to x squared? What would that look like? Well, of course, you should know this already. If I draw this out, look, it's going to be a parabola, and it's going to have its minimum point there, its stationary point at 0, 0. But if I add things to this, if I change it or I multiply it in some way, I'm going to affect the shape of the graph. And we're going to think about what that means and how that works. And I won't go through all the explanations of why this is happening in this video. This is something you should know already from your prior work. But if I add some numbers to it, so for example, if I was to replace x with x, I don't know, minus 7, what would that look like? Well, in terms of the algebraic side of this, of course, it would just be x minus 7 all squared, right? That's the function. And what would that look like? Well, it would have moved it to the right 7 places. It would have gone over here, and it will be identical, except that it would have all shifted to the right. This point where it touches is 7, 0. And if we were to also consider, well, if I just, kept f of x exactly the same, but instead of swapping x with an x minus 7, I maybe added 2. Well, what that would do, it would move that original graph up 2 places. Algebraically, it would look like this, x squared plus 2. And geometrically, what would happen is it would look just like this, with that minimum point now at 0, 2. And we can combine this and make this a little bit more formal and have some better notation, but we can move things left and right by replacing x with a value, x plus or minus something. We can move it up and down by just adding or subtracting something on the end of the function. So formally, and this is the nicely written out definition, this is what we're talking about here. So if we add something, a plus b, we're going to be moving it upwards. If b is negative, we're going to be minusing something. We're going to be moving it downwards. If we replace x with x minus something, we move it to the right. And if we replace x with x plus something, we're going to be moving it to the left. And we can display that by using a column vector. AB, the vector AB, means a movement A to the right and B up. That's the sort of notation we're going to be using to describe these things. Okay, so let's move on and have a look at a quick example of what that could look like. So here we go. We've got a graph f of x, and it's defined there. It looks very unusual, but that's okay. No big deal whatsoever. If we now were trying to draw that same function with 2 added to it, what would it look like? Well, this is the answer to part A, so we'll do A in a nice yellow pen. We'd move every point up. So we 2 positions. So it would look something like this. Every position moved up 2 places. If we're looking at part B, let's use the orange pen to describe part B. X has now been replaced with an x plus 4. It has the effect of moving everything to the left 4 places. If it's minus, it will move to the right. If it's positive, it will move to the left. So we'll mark the new positions of every point. And hopefully you can see why. I'm just sort of, a slight mistake there. Hopefully you can count across yourself 4 places to see where this is happening. And our new function is going to look like that. Okay.